All right, last two questions. If shoppers enter a store at an average rate of R shoppers per minute and each stays in the store for an average time of T minutes, the average number of shoppers in the store at any time is given by the formula N equals R times T. This relationship is known as Little's Law. The owner of the Good Deal store estimates that during business hours, an average of 3 shoppers per minute enter the store and that each of them stays for an average of 15 minutes. The store shopper uses the Little's Law to earn that there are 45 at any time. Okay. Little's Law can be applied to any part of the store, such as a particular department or the checkout lines. The store owner determines that during business hours, approximately 84 shoppers per hour make purchases. Each of these shoppers spends an average of 5 minutes in the checkout line. At any time during business hours, how many shoppers on average are waiting in the checkout line to make purchases? Okay. So if you notice, the only difference here is that they're using shoppers per minute along with 15 minutes. Here they're using shoppers per hour. So we'd like to get shoppers per minute. So that's what we're going to do. We're going to do a unit conversion. So shoppers per hour, and we have to go from hours to minutes. So hours here, minutes here. There are 60 minutes in 1 hour. So it turns out we're going to need to divide 84 by 60. Calculator will help with that. 84 divided by 60 gives 1.4. 1.4 shoppers per minute. And we have that doing for 5 minutes. We multiply according to Little's Law, and we end up with 1.4 times 5, and we end up with 7 shoppers. So the answer would be 7. The owner of the Good Deal store opens a new store across town. For the new store, the owner estimates that during shopping hours, an average of 90 shoppers per hour enter the store. So again, we're going to need to convert. Let's start this problem by converting that right away. Shoppers per hour, just like we did for the last problem. We would multiply by the conversion factor. We would need 1 hour here, 60 minutes here, so that the hours will cancel out. So 90 over 60, right, is how many shoppers per minute. And of course, you could reduce canceling the zeros. 9 over 6 is 3 times 3 over 3 times 2. The 3's cancel. You get 3 over 2 shoppers per minute, also known as 1.5 shoppers per minute. Enter the store, and each of them stays an average of 12 minutes. So according to Little's Law, we multiply this by 12 minutes, and then the minutes will cancel out. And we do 1.5 times 12. So half of 12 is 6. Add that back, you get 18. So 18 shoppers would be the answer to Little's Law there. Okay. The average number of shoppers in the new store, so we just found that to be 18, is what percent less, okay, what percent less than the average number of shoppers in the original store? Okay. So the original store had 45 shoppers. So the question is, 18 is what percent less than 45? Okay. And to turn that English into math, we use our Math English Dictionary. So 18 is means equals what percent less than? So that is a multiplier. So we'll call the multiplier x right now, and we'll do 45. So now we have to solve for the multipliers by dividing by 45, and we end up with x equals 18 over 45. So 18 over 45, that equals 0.4. So 0.4 is the multiplier that we need. And this is if we turn it back into a percent by multiplying by 100, that turns it then into the percent on. So this is the part that we would have to pay, so to speak. To get that back to a percent off, we would have to see what from 100 would equal that. So it looks like 60% off would be equivalent to a 0.4 multiplier. So actually, we don't need that number. We just need the 40% because, yeah. So the answer is 40, right? 40%. Because that's the percent that this is of the original.